Okay, we're now after the John Chappell lecture by Dr. Andrew Bartlett, and it was very interesting. And now we're going to have a little bit of a panel discussion, a little bit of planned questioning here. And since he is our guest and he is the one going to be leading some of this discussion, I thought I'd turn the tides on him. Don't say tides, but and ask him a few questions. So I'm going to ask these in easiest to hardest punching. I've got 3 questions here for you while you're talking here. First of all, tell us, why did you choose dissidence? Obviously, your study of science, discord and controversy can happen in the mainstream. Why, Mike, why did you pick dissidence?
Well, I'll start one question further along, which is why I chose discipline physics. Why we chose discipline physics. And the reason we chose discipline physics is when we were thinking about the various sciences we could study. The problem with studying something like, say, unorthodox or heterodox or dissident, say, medicine, is there's always the accusation that someone's out there to make a quick buck. Someone's out there selling their remedy or their theory about medicine. And so there's always the accusation that what's going on isn't actually science, what's going on isn't actually medicine, but it's some aspect of fraud. And then thinking about biology, which is obviously where my background is, there's always the problem when you look at that, is that the sort of largest or most pronounced dissident movement in biology is intelligent design and creationism. And there's the argument that what's going on there isn't science either, because they're not behaving by, say, scientific principles. They're fitting the world according to text and a preconceived idea of what must exist, and then finding the evidence for that. When you think about, and then let's say something like dissident archaeology, well, as we were talking earlier, that produces a mass market dissidence. If you write a book saying, I've interpreted the archaeological evidence around Stonehenge differently, great, you've got a paperback book that might make you a fortune. Now, unfortunately, one of the reasons unfortunately for everybody here, one of the reasons why dissident physics is so interesting is nobody's making a fortune. Therefore, we can pretty much rule out accusations of charlatanry, of fraud, and to a large degree as well of following a particular, of producing particular scientific ideas because of, say, political or religious convictions. So that's why physics over any, it was sort of, this is as much as we can find a pure case, so we can reduce the variables down to, questions of scientific debate, of social aspects of science, rather than all the sort of extra scientific ideas such as religion, politics, money, and economics, and so on.
Well, that's very pleasant to find out. You picked us because we're incapable of making money.
Well, incapable of making money produces...
We make an easy study.
It's honest, you can be fairly sure, you can go and present, I can talk about this to other sociologists, and they can't just raise their hand and go, yeah, well, the reason they're not accepted is because they're a bunch of charlatans who are pushing a quack medicine. Or the reason they're not accepted is because they're not actually scientists at all. They're astrologers. Or they're not actually scientists at all. They're religious studies students trying to fit the fossil record into an ancient book. That's not an accusation that can be made about this group. These people involved in dissident physics are largely doing it because they love science. They're not involved in some kind of fraud. They're not involved in some kind of quackery or anything like that. These are people who love physics and at great personal, emotional, and financial expense want to pursue these questions, pursue scientific questions. And so when we're then looking at the kinds of interactions between dissident physicists and the mainstream, we can reduce, we can concentrate on those kinds of, on the kind of questions of how the barrier operates when ideas are essentially scientific, that are trying to penetrate the mainstream or penetrate popular consciousness. consciousness or whatever it is.
Okay, I think that's pretty fair to say. I would say that most people here, there is not too much other motivation than the actual pursuit of what we hope is a better understanding of the universe. So I agree with that.
Before you go on to the next topic, may I pose a question concerning what Dr. Bartlett has just said?
That you can, yes, go ahead.
All right.
That's what I'm...
Would one of your underlying reasons for focusing on dissidence be that dissidence is one of the most effective measures of making science or any other area, art, and so on, progress, and consider new ideas?
Well, I mean, that's one of the reasons to study controversies as well. But I hadn't thought about it in those terms, actually. I hadn't thought about it as, I mean, you're probably right. You know, dissidents, revolutionary ideas are sites in which progress is made, and rapid progress is made. I'd more looked at it almost like, let's say like the ripples that are created. It's not actually the stone dropping into the water that interests me. It's all those the sociological ripples produced by a controversial idea, more than the controversial idea itself. So less so what the controversial idea can do. I mean, that's an interesting larger question. But what the controversial idea does to the communities in which it's sort of being proposed.
So in other words, you're saying sociologists go to car races to really wait for crashes.
Yeah, the analogy would be that, yeah. Well, actually, sociologists are so boring, they go to car races and they probably study the hot dog vendor. You know, and we look at the interactions and we sort of try and say something about class and gender and ethnicity and so on, and we forget the car race was going on entirely.
Dr. Bartlett, because I had this question a little bit, starting with, what exactly was it that drew you to having an interest and desire to study the issue of controversy? And are you trying to understand it in order to maybe reduce it, or to find out how to turn it to a productive purpose?
That's a good question.
Stump the sociologist?
Well, what do you mean when you say reduce it? Do you mean like producing a scientific community without controversy?
I'm sorry?
When you say reduce it, do you mean that like as if my goal might be to produce
I think that would not be a very fun or
No.
productive society.
No.
But I think controversy is innate to the human condition. You get two people in one room and you're going to have some controversy.
If this work was to have sort of larger political and social impact,
Yeah.
you'd love it to, but
Yeah.
it probably won't. You'd want what I'd be expecting is for people who are not involved in the controversies and perhaps lack the technical expertise to assess the positions for themselves, to be able to look at a controversy and recognise what's happening socially or what has happened socially.
Yeah.
So that's not to say that they would take the, say, marginalised side's position, but they'd understand that it often isn't just that knockdown experiment. There's greater processes at work, and that's not that I would be expecting that somebody reading my work, for example, wouldn't believe in special relativity, general relativity, and Michelson-Morley, but
Yeah.
just to understand that science, understand that the history of science and the settlement of controversies isn't done ahumanly or asocially. It isn't, here we produce the machine, here we produce the experiment, and bingo, we've proven it to everybody. There's all the persuasive and social work that goes on after that to settle things.
Okay.
But also to understand that the presence of controversial ideas doesn't mean I mean, one of the problems in the public presentation of science is that science is either presented as entirely certain, so we have a cover of a popular magazine that says science has found this, and things are overstated, or things that aren't particularly controversial, at least within the scientific community, are represented as if they've got real scientific, as if there's a real scientific controversy going on, and two scientists are set up as opposite talking heads, and the members of the public are almost asked to choose between them. And neither of those are particularly healthy views of what happens in science and the sorts of disputes that take place in science.
As we learned from a president not too recently, but a little while back, if you want to discuss about something that everybody knows a lot about but doesn't understand, like sex, you have to define it. So how might we define controversy? And let me give a thought, just that controversy arises out of difference. The difference is what is really innate to human experience, because we all have different beliefs and different things that benefit us or hurt us from each other. Controversy could be defined as something unproductive that arises out of differences because you don't have the right social procedures and rules for dealing with it. For example, when you run into a difference, if you get angry because it's different, that's controversy. If you run into a difference and you get curious about trying to understand the difference and you try to draw out each other with an open mind to understand it, you may deal with the difference without controversy. So I'm not sure whether controversy per se, depending on how you define it, is such a good thing. As it is, it's a good thing it exists because it means that we have a place we can have an opportunity to grow. It depends on how we deal with it.
But I suppose if you've got one experimental group, I've got an experiment, it's not the same as the second one, and they interpret the results in one way. The second experimental group have a different technique and interpret their results in a different way. Then I don't see how any amount of sort of open mind, that people are committed to certain ideas, entirely healthily committed to certain ideas and certain experimental techniques and ways of interpreting the data. Those two groups aren't going to agree. What happens is which of those two groups persuade their immediate peers in the scientific community that their interpretation of, let's say, the excess heat and cold fusion experiments, which of those groups persuades the rest of their community and their peers that their interpretation of what these observations is the correct one. It would be nice if we had a system where those two groups could come together and arrive at some kind of hash out position that united them. But given that's not going to take place, what we're looking at is the process by which not those groups get their minds changed, but by which their peers and perhaps people in related disciplines who might use their results in their own work come to believe that one is correct, one or other interpretations or experimental techniques is the truth.
Maybe I add some small things to the question why was the physics chosen on your side, because I think that physics has a specific position among the other science or branch of science, because the physics is directly connected to the picture of universe, and this picture of universe is directly connected to a rule of power, of ruling structures. We see it all 3,000 years, firearms all everywhere. There were physics, and it was connected with the forced structure of universe, how it works, and so maybe this is the reason why also the physics is so. But we heard that you mentioned the experience of all what you are searching in your research also. But I think that it is necessary to include this power line, the power of structure of ruling power structure when you will search the physics as a special science in this, and I think you have to include this point that physics is directly connected to having a power, or having a power structure or ruling governments, it has really direct connecting us small things that, for instance, when I on the Eastern on the radio, there were main mass, the highest of religion chief in Czech, and I turned it back away and I said, oh, I will not have this. And I thought that later, I thought, no, I will have it. I'm sure that in 10 minutes it will be in Big Bang. No, I was wrong because it was just 5 minutes. And in 5 minutes, I turned, it was the main mass on Eastern days, and he told that physics confirmed the truth of Bible. I have to say it is that way. So you must, I think, include in this really these questions which is specific for physics. So
when I'm right, I have to retrospectively justify my decision.
And this is directly connected to the amount of voters when the elections are this is fully connected. Who rules in the country also in nowadays.
I would say, well, I might have to, I'll probably end up having to write about this when I'm writing papers, talking about the cultural, as you said, the cultural and political place of physics. And perhaps its cultural dominance has perhaps been eroded in the past, say, 20 years by biology. You look at science fiction, and in the 50s and 60s, everything was nuclear. There was nuclear-powered cars we were all going to fly around in, or whether it was the Incredible Hulk was produced by a rogue atom bomb test, or gamma bomb. Whereas by the time we get up to the Ang Lee version of the Hulk, it's a genetic experiment. It's all about the DNA. It's all about because science has great cultural value, and of course for the vast majority of certainly the latter part of the 20th century, physics was the prime. It wasn't just big science as in supergliders and things like this. It was culturally the central science, the image of the sciences. One of the other things which is not why I chose physics, but perhaps it's not consciously why I chose physics, but perhaps one of the sort of related reasons that sort of runs along concurrently with why I chose it is that, of course, it's possible to do some physics without needing large pieces of apparatus yourself. You can do theoretical physics. It's very difficult to do theoretical biology in quite the same way. There are journals of theoretical biology, but it's not the same kind of, doesn't have any great cultural power. When we think of a biologist, we think of someone who actually gets their hands dirty with biological matter in some way, whether it's going out and collecting samples or dealing with biological material in the laboratory. The same with a chemist. Theoretical chemistry exists, but the image of the chemist is certainly not someone who works purely with equations. At some point, they get the chemicals out. They go to the laboratory and get to work. And these things are expensive and beyond people, beyond the material resources of people who are outside, a laboratory system, whether it's industrial or academic. But physics has as you all know, theoretical physics is a highly regarded part of physics. There are, large numbers of professional physicists who never touch a piece of experimental apparatus, and so it is something that it's possible to participate in without necessarily needing to hold a position at CERN or hold a position in a university. It's much more difficult to take part in, say, genetics if you don't have a laboratory to help you, to give you that persuasive power to take part, to give you the resources to examine your own ideas in the physical world.
I call that the Great Chinese Wall.
What's that?
Around the professional hat rack.
Yeah, how do you allow controversies be taken as legitimate avenues of education. For example, if a student is asked, what do you think about so and so? And the student says, rubbish. It's likely to fail.
Yes.
So he is expected to regurgitate what has been taught in the class. But if he says it's rubbish and he gives reasons why he thinks so, he should get marks. Because there is no way, as the president says, there is no way of.
I don't think there's any way to solve that. It's certainly not until you get into until you get into the levels of education where you're producing your own research and PhD, and even then it's difficult. Because part of education is becoming socialised into the knowledge and values of the society you're going into, whether that's just being socialised as, let's say, an American, or being socialised as a physicist. I don't think there's any way around I don't think there's any way in which you could productively bring controversies into the classroom as a part of, say, a science curriculum. I think then you end up with the untended garden. If everybody in the science class can produce their own iPhone, what would we be asking of science teachers then? They'd have to be able to assess, they'd be put in the position of having to assess all their students' different ideas. I think there's a role for studying controversies in studies about science. So studying how controversies are settled, understanding the messiness of science, understanding the history of science, and the normal work of science isn't that we'll see in, say, presumably an American PBS documentary. As informative as they are, and as well researched as they are, the stories are often quite messy. And the problem with the stories are often told in a very personalised way. It's personalities and great men. It's that sort of vision of history, rather than how a group of people came to be convinced, the scientific community came to be convinced. But are you imagining that you could have a situation, say, at high school level, where students could be taught about relativity and write essays saying but university, at undergraduate level?
Yes. Even at postgraduate level.
Well, at postgraduate level might be a different thing, but even at undergraduate level, as attractive as the idea is, I would struggle to imagine how it could be workable, given that you'd still need to have, an exam. Given what the function of education. I know that education is meant to open minds, but it's also meant to impart certain ways of seeing the world. Unfortunately, I struggle to see how you would examine students if the subject of the essay was produce arguments for or against relativity theory. That's one thing. If the subject of the essay was describe Einsteinian general relativity or something, explain in your own terms how the argument works, and you don't do that, you're so trapped in the way the education system sort of has to work, or the scale it works as well. I don't see how you could have a position where, because it wouldn't just be for general relativity, you'd have to say it could be for everything, and the teacher or the person marking the exam, who might just be not necessarily going to hold necessarily tremendously advanced qualifications and all these things, is then going to have to assess the technical and argument, correctness of all these different opinions across all these different subjects. Because it wouldn't just be the controversy that you like to bring to the classroom, it'd be all controversy in the classroom, wouldn't it?
Yeah, it's interesting you talk about that. A friend of mine, a Brazilian, who has been at this conference numerous times, he's in the engineering part of the university across from Rio de Janeiro. He had a course and was teaching his students in a very different way. Now, I think the way I look at it, he came up with a model. In fact, I wanted to use him as a model until I got a call. I talked to him on the phone this year because it was part of this new outreach. And he says, don't include me in this model right now. And you can imagine where that came from. But what he did was pretty remarkable. And the way I look at it is you can do it in a university setting. What you do is, especially at the graduate level, maybe even the undergraduate, because when you take a class, you don't take just math in one class of math, you take a series. And then, especially in the graduate level, you take different classes for different purposes. And what he did in this one class, let's say you teach physics, so this is the way it is today. So you take that course, and now you have another course, and that course is critical thinking. And what he did is he said, you pick a subject, just pick one, Big Bang, relativity, whatever. And then I want you to research it and come back to me and tell me what you found. And yes, it's much more subjective. It's not easy. It's not, you don't have, but you go into that course in a different way.
And then that's a course in critical thinking.
Yes.
Whereas if you were teaching a course on special relativity.
Right. But I'm saying you can separate those two into
yes.
two. And what he found out was really interesting because he said he found out that, I mean, to give you two things. One, a student would come to him, he'd say, and they come back and says, okay, yeah, there's special relativity, it's pretty well accepted, it works everywhere. And he's going to go, you haven't looked at it. I know this for a fact because there are in fact thousands of people looking differently. You have not completed a thorough look of the landscape, please go back. And then when they did and they came back, the pressure and what he found over a number of years was that there were three groups of students. One that really took this on, and this was really beneficial to them. A second group that just did it because they wanted to do it, they had to do it. And they weren't really motivated by anything. I get my degree, what do I need to write out on the test? That's fine. The third group was literally rebellious. And that group actually, I think, caused so much problems for this professor that kind of teaching was then discouraged. But I think when we're talking about this, Harry Ricker, when he reviewed Einstein Wrong, the documentary, he came up with this phrase, which I think is totally relevant to all of us. And he says, what, David, he said, I see what's happening here. This is a social revolution in science. We don't teach correctly. We teach the right answer. This is what it is. So when we were talking about the engineering student, both of them will do well in the test, and the guy wanting to be the physicist. It's a different reason why they're doing it, but they both are contributing to not moving science forward. So that's one of the things that with the teaching, that I think it is possible. But the question is, are we ready for that kind of social, because it has nothing to do with science. This is not a scientific problem. Where do you pin that? And this person called it a social problem.
Let me add a little bit to that, if I can, David, with kind of a sort of a wry joke, but I think it's the point across. That is that the children are born with a remarkable ability to each interact in their own way with the universe. We send them all to school to train them to think and act alike. As long as that's true, we're not going to have the kind of information-seeking, curious. What we need to focus more on when we're doing is teaching them how to think, not what to think. And we need that going on from kindergarten up, a lot more than we have.
I'd agree entirely with that. But then it's not, that would also be true if mainstream physics is entirely correct. And mainstream physics could be an exact mirror of reality, and what you say would also be true. It's not a question of whether mainstream physics is right or wrong. That would be a revolution in educational practice and the purposes of education, which would be an extremely attractive. I'd love to see that put into practice, and that's a bit different from say taking a high school physics class and teaching the controversies there, because that that would just be a piecemeal approach, as it were, because you'd be inserting into an educational system that's meant to certify and say, these people know about special relativity and they know how to produce the arguments of special relativity. And you'd be inserted into that in a way that somebody could get that certification when they produced arguments that said special relativity doesn't exist or it's wrong or whatever. You want that person at the end to come out with that certificate because of what it says, essentially what it says about the person. And that person knows the arguments of mainstream physics and knows how to reproduce them. So if you had a system, that was much more rewarded and emphasised critical thinking across the board, then these questions, that wouldn't be the same kind of objection as I would have to it now.
I think also what happens is when you're teaching, you have to understand, it's really funny, the person who I think who knows more about special relativity on the planet is Dr. Karazan, who studied it more than anybody. He, from what I've seen, he has. So, in other words, to get to where he found these mistakes, both physical and mathematical, when he was 20 to 24 in 1940 in Argentina, he had to know it very well. In fact, he had to know it better than the people who study it and pass it on. And that's what we have to do. We, all of us who are in an area, have to learn it. So I don't think that it models that hard. For you to be critically thinking, you can't pass things. I'm an artist. Many of you saw the drawings I did. You can sit in front of me, I can draw reality. Picasso, who was an incredible artist, not because his paintings went for long. If you study him, he was painting realistically and drawing at 12, 13, 14 years old. The reason his abstracts are so good is they're based on reality. He had a path to it. You can't, the word abstract comes from the fact that you take reality and abstract it. We can't expect, and I think a lot of times mainstream physics, in fact, physics on the fringe, Margaret Wortham, she says, excuse my language, horrific things. She says that this group in particular doesn't have the capability to understand at the level that physicists have physics. And so we are like children. We go off into our corner and with Legos build our little models of the world. That's what's being perpetuated. But if we teach, for us here to understand and talk, I think it's implicit, we don't even think about it, that if you're talking about waves, you better have studied waves. And if you haven't, and the guy over here has, he's going to jump on you. That's a product of what this group does, which is really great. But the educational model will follow that. For you to say Einstein is wrong, you better know what Einstein said, just saying he's wrong. You go to, a good example of how this is violated are artists. If you look at most visual arts, 95% of them are bad. Why? Because they say, I don't need to draw reality. I can go directly to abstract. And what happens? Me as a person who, when you see my abstract, it's got balance of color, it's got balance of line, it's got composition. All the same things it's hard for me to do as Picasso when he makes a funky drawing of you when he does a real drawing. If you ask me as an artist in my head, I am still using those same rules. It's the same way here. I think education can live. You can't just have a free-for-all, just say what you want to think. It's got to, you have to teach it. So, in other words, what we're really doing is we're teaching this part, and the critical thinking we're not teaching.
But what you have, what you're addressing there, I think, which is important to understand this, is that there's a balance between doing your homework on the one hand and understanding it versus coming to where you think like everybody else. Because you were asking earlier, how do you get the professionals to open up? The way you posed the question is, how do you allow people who aren't really full professionals to be heard? Okay. And I would argue that that's getting the professionals to realize more completely that the only ideas from which you can learn and grow are to be found among those ideas with which you don't already agree. And unless they are willing to listen to those who've learned slightly differently, they're not going to encounter as many ideas they don't already know and agree with. And so they're cutting off their own source of ideas for knowledge and growth. It's to mutual benefit.
Yeah. And then the question, perhaps we can explore maybe in the, after we've had a coffee, is the marketing of the CNPS.
Right.
The question then would be, we could all, you could all wish the mainstream to have a different attitude, but that's not going to do anything.
Mm-hmm.
You can change what you do, perhaps. What I know you're relatively pessimistic about being able to change things and reach mainstream scientists, but what changes perhaps, what changes are on the table that people in your position are able to make that will allow you to engage with mainstream scientists, even if only slightly more successfully. I know David's pessimistic about the ability to do this, and I understand entirely where you're coming from.
Well, I just think history has never shown, and I will be the first to say congratulations, but I challenge anybody to find a time in history where a mainstream has flipped on a paradigm shift. And I have not found it. That was the first thing I did when I learned about dissident science. It's not that I'm pessimistic. I'm just looking at the history. And I can't find it, and I would love to find that example. Even Newton, I said, Newton's got to. And I literally looked at all the books, and only about one or two mentioned the controversy of him spending the rest of his life defending to his peers who didn't believe his stuff.
Well, I am optimistic.
But I mean, for the mainstream, there's a difference between here's, I think, before you go, and there's two things. There's an optimism of making a paradigm shift. That is what we want. We want a change. We need to move ahead. We've been spending 100 years chasing unicorns. We know that. Now the question is how that happens. History, at least for the last 3,000 years, has shown it never happens by convincing those in power to change that. Now, what I'm saying is, I do not see an example in history where we change those in power to that. But I see all kinds of stuff where I was talking to you, that if everybody and all the students start doing a hackathon on the universe, and they're all working on it, and they're building the universe, they don't care about mainstream, it's gone around them.
Very few sentences important to this. Who are the mainstream? Maybe you can touch somewhere that the silent majority is a very important category. As I mentioned, I was on 2 physical conferences last year in Denver and in Savannah. In Denver, it is the biggest conference in the world. There is 10,000 physicists. I had a talk and I was really afraid. I was talking about special relativity, about degeneration of momentum and energy, and the auditory really had a very great applause. I didn't never wait this. I thought, oh, there will be so what. They even it was almost stand up to applause for me. So you have also to concentrate on who are the mainstream and where is the silent majority in this category.
Yeah, that's true. And you said something too, the silent majority. We'll get to you in a second.
Can I just say something about the Newton case? In a way, there's a way to see, your reading of the history of Newton actually very optimistically, although it doesn't bring you any reward in your lifetime. in that.
I don't like it.
You're talking about these cases where the way that the history of science is popularly written, which is someone produces an idea, whoops, the whole everybody's understanding of the universe changes all of a sudden, when actually it's much more gradual, and sometimes these people never really see their ideas take hold. Well, if that's actually the normal story of science, then it's a way to not be discouraged about the immediate impact of your ideas. It's this idea that you might write something and it slowly bubbles through into being used in other people's work, and you might not see the day when it's widely accepted, if that's your reading of the history of science.
It's true. I mean, even in the movie, in my own movie, I talk about that, and I say, I just want my daughter to know, when I'm gone, to say, you know, my dad hung out with these guys. He really questions stuff. I mean, that may be all I have, you know, because in some sense, we are human beings. We want to think we've contributed to the dance of life. Artists have that same problem. You paint your stuff. I know I've got some great stuff. I know people even collected great paintings. You know, I don't want to go the commercial route. And maybe 100 years from now, since I painted so little, they could go for a lot of money. But then, you know, where does that be? I can't fund this institute with selling one of my paintings for $5 million because it's not going to happen until we're all dead.
Can you say on the question of who is the mainstream? And unfortunately, that you know, there's no real way around saying the mainstream of the people who you control the well-read journals.
There are the bosses,
Yeah.
bosses on the highest places, and
But also but not just the bosses.
very interesting on the talk on the video conference. There was a man from SAP. It was 3-4 months ago.
Yeah, I remember.
It was very interesting. He came directly from SAP.
Yeah.
From LHC,
Yeah.
and he told that in his group, if I could remember this, that in his group, about 16 people or so, just 2 believed in that experiment.
Well, I think what you said too is one thing that you said, which is very true, which I do have a belief, which is some optimism. But it's not in physics, in the physics world, who control that, which is actually the part, when I did these statistics on the number of people who specialize in these areas, they're zero compared to statistics. They don't exist practically. But if you look at the silent majority, which you call, which are the engineers who write all this stuff off every time they pick up an article that says dark matter, you know, engineers look at this and, you know, wake me up when there's something real. And that is something where you can, you know, maybe what it is, it's a shift to a different population. I mean, for you to get, you know, well accepted wasn't with theoretical physicists, right? These aren't theoretical physicists. They're physicists. Most physicists aren't theoretical.
Yeah. One of the, having talked to quite a few disciplines, I think one of the problems that people in your position face is, again, knowing what's going on in science beyond the surface of the papers and press reports. And actually, you know, I remember you telling me about speaking to scientists, and they say, well, we're not willing to go on record on this, but we believe in X, Y, and Z. And you just there say that only 2 people in the team believed in whatever it was. There's a lot more heterogeneity within professional and academic science, within the mainstream, than is presented in the sort of reading of the surface of science that's available to outsiders. And this is why sociologists always want to get inside science and psychologists to find out what people are actually doing. And in a way, you know, when you've been talking science, you know, not on record, you're essentially doing a sociology of science. You're doing a sociology of knowledge. You're showing that what appears from the outside to be a homogeneous certainty about what exists is actually, you know, much more. There's actually much more variety in there. And regardless of what's in, say, the papers, what you also find out when you get into science and talking to scientists is most papers aren't read. Some areas of research aren't